This lesson is about voting systems. So in America, we vote for different elections quite often. So we have, local candidates that get voted for, and then you get the presidential candidates that get voted for. And we have all these ballots where we go and we fill out, and it's a pretty normal thing for us. We also just have things that you vote for, in your day-to-day life. As a student, you might vote with your class on who you want to be for class president, or you might vote about what you want the theme for prom to be. So we vote on a lot of different things. There are actually different ways that you can determine the winner when you vote for something. And this is something that comes up every now and then with different elections and different politicians. People will say, we should vote in a different way, and this would make more sense to vote. So that's what this lesson is about, is different ways that you can actually vote for candidates. Okay, so most of the time in elections, then the way that we do things is you just pick one person. You say, okay, I would like, option A versus option B. I would choose to go with option B, and that's it. Okay, but a lot of times you'll have like a ballot where there's many different people that are available or different options that are available for something. And then you need to make a choice. So this example here is this vacation club. They're deciding on where they want to go for their vacation, and they've got 3 different options. So most of the time when we vote for things, what we do is you just say, oh, I vote Hawaii, or I vote Anaheim, or I vote Orlando. So to begin with, there's an alternate way that you can collect information from people. So there's a particular type of ballot that is called a preference ballot. So a preference ballot, okay, is where instead of just saying, I pick this one thing, you actually rank your choices from most to least preferred. So in this case, as you look at this sort of table, so I abbreviated Hawaii, Orlando, and Anaheim to HOA. Okay, and you can see that each of these people who had to vote ranked the 3 choices. So Bob, for example, wants to go to Anaheim the most, but if he can't choose Anaheim, he'd rather go to Orlando over Hawaii. Versus, say, Anne, who also likes Anaheim best, but if she can't go to Anaheim, she would rather go to Hawaii than Orlando. Okay, so everybody just goes through and they rank them based on how much they like each thing. Okay, so then what you do from there is you would take all of this information and you combine all of this together into what is called a preference schedule. So preference schedule. And that's what this guy is down here. Okay, so what you do from here is you go through and you say, okay, well, Bob said Anaheim, then Orlando, then Hawaii. How many people agreed with Bob? Well, let's see, Anne didn't, Eve didn't. It looks like nobody. So this particular order of Anaheim, then Orlando, then Hawaii, only one person voted for that. So we'd say that one person chose this. Okay, Anne, she wanted AHO. How many other people did say that? Well, Bob's already out, right? Eve also said that. So that's Anne and Eve so far. So we're at 2. And then Jim also said that, right? So that's 3 people, those 3 that all together said the same order there. Okay, the next one, OHA. Did anybody else agree with Marv? Omar did, and so did Dave, right? So Marv, Omar, and Dave, those 3 people, ranked them in this order. And then last but not least, Alice and Lupe, or Lupe, I don't know how to say that, right? The 2 of them agreed in this particular order, so there were 2 here. Okay, so basically you just kind of combine it together. You say, okay, how many people said each thing? The total number of numbers up here, so 1 plus 3 plus 3 plus 2, that adds to 9. Okay, that should add to the same how many people we have here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I missed somebody. Oh, Tish. I missed her when I did this one, right? She was also with Alice and Lupe. So that should be a 3, not a 2. There we go, fixed it. Now, these all add up to the same number of people that we have here. So everyone's been represented. Okay, so this is called a preference schedule, all right, and that's what we're going to kind of look at. So when you're voting, so the first thing that would have to change to use most of these voting systems is that instead of just going in and like having a multiple choice question where you choose one answer or the other, it would have to be a question where you would say instead, rank these candidates from your first to your last choice, okay? So we're going to look at 5 different voting methods using this table of data. So this is just a preference schedule that I put together. 18 different people said that they preferred this, 12 people said this, 10 said this, 9, 4, 2. Okay, so I took all of these votes already and combined them together into a preference schedule. So the first method is called plurality. That is the most commonly used method of voting, and that's what you're most familiar with. Whoever gets the most first place votes wins. So when you look at a plurality vote, essentially what you do is you ignore everything in this table except the top row. Okay, so people looked at this, right? This was their first choice. So that would be the only thing that you get to vote for is who's your first choice. And if we looked at this, then 18 people said B, 18 said A, 12 said B, 10 said C, 9 said D, and actually 6 people said E, right? Because both these 4 and these 2, so 6 altogether said E. So if we were voting using plurality as our way to judge our winner, in this case, our victor would be A, because they had 18 members. So in this particular method, our winner was candidate A. Okay, now, what are the strengths and weaknesses to this? Well, the strengths are that it's really easy, right? Like, it is very easy to just have everybody fill in a multiple choice question, pick who they like most, and just compare what they got. This is the easiest method by far to figuring out who the winner is, okay? So that's definitely a strength here. But there are some different issues with this. So one is that it's possible to have a winner who did not win the majority of votes. So all these people together add up to 55 people. Okay, so 18 people out of 55, if we actually calculate that, 18 people out of 55, that's only about 33%. So candidate A wins in this case, but only about 33% of people actually liked that candidate best. So they got the most votes of everybody, but they didn't get the majority of votes. They didn't get at least half of the population who said that they liked them. Okay, and another potential issue is that the winning candidate can also be the least popular choice. If you look at everybody else's preferences and where they ranked candidate A, right, these people said they liked him best. Everybody else hates him. He's at the bottom of the table for every single other person, right? So you've got these 18 people who they're like, yeah, I am pro candidate A, but the other 37 people represented in this table all hate him. So 37 people now have to deal with the candidate that they hate the most, because 18 people said that they preferred him. Okay, so plurality is great. It's easy and convenient. And if you only have 2 candidates, it's pretty easy to use, right? But whenever you have an option where there's more than 2 candidates that you have to look at, it's really not necessarily always the best. Sometimes it could be, but not always. All right, so that's method number 1. That's the plurality vote. Method number 2 is called runoff. Okay, so in runoff, this is basically where voting is done in 2 rounds. After the first round, so basically the first round, you figure out who are the top 2, and then everybody re-votes. And then from those top 2, you say, okay, well then who would be the best from there? Okay, so what this basically gets rid of is, in this option where we did plurality, the fact that, these people got the most votes, but everybody else hates him. Right? This allows these people to then say, well, wait a minute, just because A got the most votes, now I want to say, okay, literally anybody but A, right? So that's what this runoff method does. So what runoff does is it says, okay, you're going to go through and figure out who are the top 2 candidates. So again, looking at our first choice options, A got the most choices, or the most votes total, right? But then from after that, B was second place, right? They got 12. So these rest of these candidates who got 10, 9, and 6 votes, they would all basically be eliminated from the race. And now you look at it and say, okay, well then, given the option of only candidates A or B, so these guys over here can no longer vote for who they voted for. These guys are going to stick with what they said. But these guys, okay, you can't vote for C, D, or E anymore. So given the choice just between A and B, who would you rather have? Well, these 10 people, given the option between B and A, right? Again, these guys aren't an option anymore. They would rather have B. These guys, not an option anymore. They'd rather have B over A. It's their least favorite candidates, but they'd rather have B over A, right? These guys can't have those guys anymore. They would also take B. This group of people can't have these guys anymore. They'd also take B. All right, so then from there, what you would do is you say, okay, now candidate A, they still have their 18 votes, but candidate B has everybody else, these 12, these 10, those 9, those 4, those 2, they would all rather have candidate B. So what that works out to is that candidate B ends up with 37 votes of the 18. And now in this case, our winner would be candidate B. Okay, so this is basically an option. This is something that people have proposed actually for our presidential elections, because the way that our voting works right now is that if you go in, we have, often there's a Republican candidate, there's a Democratic candidate, and then there's usually like an independent candidate. But people feel like they can't necessarily vote for the independent candidate because it feels like you're kind of throwing your vote away, right? Like we know that the independent candidates never win, right? They're never even close to winning. So if you go in and you vote for somebody who's independent, it feels like maybe you like that person best and you think that they would be the best option for the job, but you look at it and you go, but yeah, if I vote for them though, like it's definitely going to be either the Democrat or the Republican. So I should just vote for one of those two people and pick the person that I like the best of those two, right? So having a runoff allows somebody to go in and say, you know what, I am going to vote for the independent, because if I choose to vote for the independent and then they get knocked out, it's okay. I have a do-over. I can still choose between these main two candidates. All right. And it kind of like opens things up a little bit more so that there is a potential for that third party to actually win because people don't feel like they're wasting their votes voting for that person. Okay. So that's the runoff method. Okay. From there, method 3, elimination. So this one goes by a lot of different names. It's also called instant runoff or plurality with elimination. So this one is kind of like how sports games work, right? You do voting in your multiple rounds. Whichever candidate has the least votes is removed, and you keep doing that until you're down to only the top 2 candidates and then figure out who had the most votes that way. So this is like starting with the losers and getting rid of them first, okay? So what we would do is we'd look at this and say, all right, first round voting, right? What did we come up with? So when we just voted for our top candidate, right? A, B, C, D, E. Who had the least number of votes? Well, candidate E did, right? They only had 6 altogether. Everybody else had 9, 10, 12, or 18. So what we would do is we'd say, all right, candidate E, you have been voted off of the island. You've been eliminated. So candidate E is no longer an option and gets eliminated from the ballot. All right, so then we go through and we say, okay, well, now what? So now if we look at what our new first round is, right, these people can't have E anymore, so now they're going to switch their votes to B and C. So now who has the least number of votes? A has 18, B has 16, C has 12, D only has 9, right? So, okay, now D's been eliminated. So D, you've been voted off the island. You are no longer a potential candidate here. Okay, so now let's look back. So these guys, we got them and we got them. Those are our options, right? So A now has 18 votes. B has 16 votes. C has 19 votes. Oh, nope, these guys too, right? So C has 21 actually. So C is 21. B only has 16, so 16 is the least, right? Okay, so then candidate B is going to get eliminated. So candidate B, you've been given the boot. All right, so now we're down to just options A or C. So these 18 people would vote A, 12 for C, 10 for C, 9 for C, 4 for C, 2 for C, right? So A got those 18, but the other 37 all voted for C. So in the end, right, it came down to C getting the most votes. And in this case, our winner would be candidate C. Okay, so that is a elimination one. So one of the potential issues with this is that you can have a candidate who's most often preferred over other candidates but still loses. You can't really see that illustrated in this table, but it is a possibility of something that can happen with these. So it's not perfect, it's not a perfect system. It's just, something that can happen sometimes. Okay, so looking at this is just another alternate way of voting where you're eliminating people and then going back to figure out your top ones. I think a lot of times with elimination, you could do this as like a revote every single time. We're like, okay, everybody vote, and now go back and vote again, and now go back and vote again, and now go back and vote again. Or you could just make a preference ballot like this and then go off of people's preferences that way. So it is doable as just a one vote. It's just a little bit different. All right, method 4, the Borda count. So this is named after a person whose last name was Borda. Okay, so Borda count is when you assign points to each of the rankings. The least desired candidate gets 1 point, second least desired gets 2, and so on, okay? And then you get points from each person, and whoever gets the most points total wins. Okay, so let's look at this. So with this particular table that we have here, okay, we have 5 different candidates. So the last bottom, like the bottom choice for everybody, they would get 1 point. Second would get 2 points. Third would get 3 points, 4 points. So if you choose somebody for 5th place, you're giving them 5 points. Okay, so then what we're gonna do is a whole bunch of math. We're gonna calculate this. All right, so let's start, and I'm gonna kind of color code to make our lives a little bit easier here. So let's start with candidate A. What are they gonna get for points? Well, for this group of people, 18 people are gonna give them 5 points apiece. So if I multiply 18 times 5, that works out to a total of 90 points from this group. 12 people are gonna give candidate A 1 point apiece, so that's a total of 12 from this group. These 10 will all give 1 point. These 9 all give 1 point. These 4 give 1 point. Those 2 give 1 point. So candidate A, their total number of points, they've got this 90 here, plus the 12, plus the 10, plus the 9, plus the 4, plus the 2, right? So that adds up to a total of 127 points. So that's how many points candidate A ends up with. All right, so now let's do candidate B. So candidate B in this group, these 18 people all gave 1 point apiece, so they got 18 points there. Here, 12 people gave them 5, so 12 times 5 is 60 points total. Here, 10 people gave them 4, so that's 40. 9 people gave them 2, that's 18. 4 people gave them 4, that's 16. And then 2 people gave them 2, so that's 4. Okay, so candidate B, if I add all those up, they got 18 points, then 60 plus 40 plus 18 plus 16 plus 4, and that added up to 156. All right, next candidate, candidate C. So C from this group, 18 people gave 2 points, so 18 times 2 would be 36. 12 people here gave 2 points, so that's 24. 10 people gave 5 points, so that's 50. 9 people gave 4, so that's 36. 4 people gave 2, so that's 8. And then 2 people gave 4, so that's also 8. Okay, so for candidate C, when I add all that together, 36 plus 24 plus 50 plus 36 plus 8 plus another 8, that adds up to 162 points. All right, next up, candidate D. 18 people are going to give 4 points to candidate D, that's 72 total. 12 are going to give 3 points, so that's 36. 10 are going to give 2 points, so that's 20. 9 are going to give 5 points, so that's 45. 4 are giving 3 points, so that's 12. And then these last 2 are giving 3 points, so that's 6. So 72 points plus 36 plus 20 plus 45 plus 12 plus 6, that adds up to 191 points for candidate D. All right, and then last but not least, trying to find another good color I can use here. All right, so candidate E, so they got 18 points from each, or 18 people gave them 3 points, so that's 54. 12 people gave them 4, so that's 48. 10 gave 3, that's 30. 9 gave 3, so that's 27. 4 gave 5, so that's 20. And then 2 gave 5, so that's 10. So if I add all those numbers up, the 54, the 48, the 30, the 27, the 20, and the 10, that adds up to, for candidate E, 189 points. All right, so then from there, we would look at, okay, all of our point totals, who actually wins. Well, in this case, D ends up with the most points, right? So using our board account, our winner would be candidate D. Okay, so we've got this kind of option. So the big issue with the board account method is that you can often have winners who are not necessarily somebody the majority wants. So like if you actually look at where D ended up in all of these, like, so here's where D ended up in all these different votes. So he wasn't like a really disliked candidate, but he also wasn't really particularly liked, right? Like only 9 people actually voted for this guy for first. He got a lot of like mid-ranked votes. So what you sort of end up with is like a lot of people who are kind of happy, but like nobody's like really super happy or super unhappy. So it is a different method. It just sort of like, you know, kind of finds you more of like a middle candidate almost. All right, and the last one is the Condorcet method. So again, named after a guy named Condorcet. So the Condorcet method is basically like a head-to-head challenge kind of thing, where each candidate goes up against each other candidate, and you see who would get the most votes if it was just the two of them. So basically, you do a bunch of plurality votes between each of the possible candidates, and whoever wins the most compared to everybody else ends up winning. So for this particular one, we've got 5 candidates. So the pair-offs that we would do is you would look at candidate A versus candidate B, then A versus C, then A versus D, and then A versus E, right? And then we'd have to look at, well, candidate B versus everybody else. We've already done B versus A, so then you have to do B versus C, and then B versus D, and then B versus E. C's already gone up against A and B, so now we'd have to do C versus D, and then C versus E. Okay, and then D's gone up against everybody else, so we just have D versus E left. So these will be all of our different matchups that we have to compare. So we're going to go through and we're going to compare each of these and see who would win in any given situation. So if we just compared candidate A and candidate B, who would end up winning? Well, let's see, A is here, but then at the bottom of everything else, right? So A versus B, A is definitely going to lose because nobody else wants A other than these 18 people. So that would be our winner for this matchup. B would win. All right, A versus C. A would get these votes. C gets all the other votes, right? Because A is at the bottom for all of these. So again, C would win. Okay, similar thought process for D and E. A would get these 18, but D or E, either one, would still beat out A because everybody else would choose not A. So these would be our winners from those matchups. All right, B versus C. So C would claim these 18 people because they prefer C to B. So 18 people for C so far, right? Then here, B would get 12. So let's see, I'm going to keep track of this, right? So for B versus C, right? 18 people chose, these 18 chose B. Nope, I'm sorry. Those 18 chose C, right? Here, 12 people chose B. Here, B versus C, those 10 vote for C. B versus C, these 9 vote for C, right? B versus C, those 4 would give their vote to B. And here, B versus C, they would go with C also. So when you compare the total number of votes, this is only 16. They've got 18 there, right? C is definitely going to win, right? So C would be their winner here. All right, B versus D. So B versus D, 18 would go to D here. These 12 would go to B. These 10 would go to B, right? These 9 would go to D. These 4 would go to B. These 2 would go to D. So when we compare these numbers here, let's see, this adds up to 26, and this side adds up to 29. So D would win in that case. Okay, so D's our winner. All right, B versus E. All right, these guys would choose E. These guys would choose B. These guys would choose B. Right, these guys would choose E. These guys would choose E. These guys would choose E, right? So we total these up, that's 22. This is going to add to, let's see, 20, 33, I believe. So E would win. So E's our winner here. It just so happens to work out right now that it's always the second candidate for all these. That's just a coincidence. That's not something that would necessarily always happen. All right, C versus D is our next one. So given the option between C and D, these guys would choose D. These guys would choose D. These guys would choose C. These guys would choose D. C versus D, they would choose D. And they would choose C. So clearly D has it for that one. So D would win. All right, C versus E. All right, so these guys would choose E. These guys would choose E. These guys would choose C. These guys would choose C. These ones would choose E. And these guys would choose E. So our totals here, this would be 19, and this would add up to 30 something. So this is definitely more than 19. So E would win. Okay, and then D versus E, our last one. Okay, so D versus E, these guys would choose D. These guys would choose E. These guys would choose E. They would choose D. They'd choose E. And they would also choose E, right? So this adds up to 27. And this is going to add up to, let's see, that's 6, that's 16, 20, 30? No, 28, right? 22, 26, 27, 28. So just by hair, but E takes it. Okay, so we figured out all of our head-to-head matches, who our winners were, and now we're just going to compare all of those and say, okay, well, who won the most, right? So B won once, C won twice, D won 3 times, E won 4 times. So E won the most all of these, so our winner would be E. Okay, now, if you've been kind of paying attention, you may have noticed that although we use the same ballot for every single one of these different things, we ended up with different winners each time, right? If we kind of go back and look, the first one, winner A, then winner B, then winner C, then winner D, and then our last one, we got winner E, right? So the thing about voting is that it's really, really complicated, right? Now, clearly, this board was set up to do exactly this. Okay, so this was deliberately designed to make it so that with these 5 different methods, you would have a different winner each time. So that was very much on purpose, and it was very carefully selected to do that. Okay, now in the real world, that probably wouldn't happen, right? Most of the time, if you took any actual vote of something and you compared all these different methods, you wouldn't find a different winner every single time, but it can happen. Okay, so there is a thing, right? It is this property of math and game theory that actually says that when you're voting with more than 2 candidates, so if there's 2 candidates, it's easy, right? Majority wins, right? But if you're voting with more than 2 candidates, that you actually, there's no one way of voting that is the best way of voting that will always give you the best choice. All right, so you can get all these different winners depending on how you count up what winning is. And that's kind of one of the issues that comes into play when we talk about, yeah, we should redo how we do our voting in this country. Sure, we could do that, but then how do you choose which system you would use? Okay, and how do you collect that information, and how do you explain it in such a way that people understand what's going on? So plurality has the option of being, or the benefits of being easy, both to do and to count, and to understand. So that's kind of one of the big hangups in the idea of changing how we do voting in this country. So it's a really interesting thing to look into and to kind of study and try to look around. So it's something to think about. What do you think is the best way to vote? And if you are the one who is in charge and you got to choose how voting worked, what would you choose?